Okay, so in class we had started this question, but we didn't quite finish it. So it's a roller coaster that's going from point A, which is up here, 15 meters high, speed of 4 meters per second, to point B, where it's 6 meters high, and we're looking for the speed here. So this would be our VF. But it tells us that that it goes from the slope from point B, which is 6 meters above the ground, to A, 15 meters above the ground. It goes down the slope to point B, which is 6 meters above the ground, and 3,400 joules of work is done by friction. So at the end of class, we said what they're trying to give us there is our E lost. And then it wants to know what is the speed at B. So we go to our nice big equation and we say, okay, here at the top, initially, does it have a speed? Yes, it does. Does it have a height? Yes, it does. Is there a spring? No, there isn't. So this stays, this goes. Here at point B, definitely a speed, because that's what we're looking for. Definitely a height, because they tell us it's 6 meters. And it tells us E lost. So the only thing we don't have is 1/2 kx squared. Okay? And so now we're going to rearrange. We're trying to solve for VF. So take your MGH and E lost over. So 1/2 MV initial squared plus MGH initial minus MGH final minus E lost will equal 1/2 MV final squared. Okay, and so now we want to get the V final squared by itself. So multiply everything by 2. So this becomes MV initial squared plus 2G, don't lose your M, 2M. You can't cancel the M's here because there's no M in the E lost. So don't lose it like I just about did. So 2MGHI minus 2MGHF minus 2E lost. Okay, so we got rid of the 1/2. Now we need to get rid of the M by dividing. And again, you can't cancel it out because there's no M in the E lost. So now fill your numbers in. The M is 200 kilograms. Initial speed 4 meters per second, and that gets squared, just the V. Plus 2 times 200 kilograms times 9.81 meters per second squared times 15? Yeah, 15 meters minus 2 times 200 kilograms times 9.81 meters per second squared times 6 meters minus 2 times 3,400 joules. And then you're dividing all of this by 200 kilograms. Don't forget to square this 4 meters per second, and then don't forget to take the square root when you're done. So before you take the square root, you should get 158.58 meters squared per second squared. So then take the square root, and you get 12.5929 meters per second. Okay, that's not bad. That's about 45 kilometers per hour, so not too bad for a roller coaster. All right, number 7, which we did not start at all in class. A 60-kilogram person, not looking like a great shape, but here they are, slides down a 12-meter high slide. So if it's 12 meters high, this is this part. If it had said long, it would be this way, but instead it's saying high, so okay, it's here. Starting from rest, so VI is 0 up here. When the person reaches the bottom, they are traveling 11 meters per second. So VF is 11 meters per second. And of course, HF here is going to be 0. The 12 meters is your HI. Okay? If the slide is angled at 30 degrees, so that would be right here at the base, what is the force of friction acting on the person as they go down? So there's going to be some E lost, and that's what we need to find first, okay? So as soon as you see friction, it's like, oh, there's E lost, so let's find it. So at the top, so you need your big long equation, and I cheated and wrote it down before I started the video. So at the top, there is no speed, but there is a height. There is no spring. At the bottom, there's a speed, no height, no spring, and E lost. So you have mghi equals 1/2 mvf squared plus E lost. And this time you're solving for E lost. You cannot cancel the m's. You're going to take this term over, so it'll be mghi minus 1/2 mvf squared equals E lost, and now fill your numbers in. So E lost will equal, the mass was 60 kilograms, so 60 times 9.81 meters per second squared, and the height was 12 meters, minus 1/2, 60 kilograms, and the speed at the bottom 11 meters per second, and that gets squared. So first term is going to be something like 7,063.2 joules, and second term is going to be 3,630 joules. Whoops, I didn't do a very good job if I don't look down while I'm writing there. So 3,630 joules. And so then when you subtract them, you get an E lost of 3,433.2 joules. Okay, so that's the E lost, but the question wants to know the force of friction. So remember that E lost is equal to the work done by friction, which means it's F delta D cos theta, but the F is friction. And that's what we're looking for. So you would divide by delta D cos theta. So friction is equal to the E lost you just found divided by delta D cos theta. So on the top, 3,433.2 joules. On the bottom, what? Well, let's take a look. Delta D, so this box is sliding down the incline. The delta D then is going to be this whole length, which is the hypotenuse. So you have the angle and you have the opposite side, so that would be sine. So sine 30 is equal to 12 meters over the delta D. So delta D is going to equal 12 meters over the sine of 30. And sine of 30 is 0.5, so 0.5 divided into 12 will be 24 meters. Okay, now the other question is, what's the angle? Just because I gave you 30 degrees does not mean that that's the angle. This is the direction of motion. This is your delta D. What way is friction acting? This way. What is the angle between them? 180 degrees. So down here it's going to be 24 meters times the cos of 180. And the cos of 180 is -1, so your answer is going to be negative. It's going to be negative 143.05 newtons. What does the negative mean? Acting opposite motion, which we know that's what friction's supposed to be doing. Okay? So there are your E lost questions. This one is as tough as I would make it. Like, I wouldn't ask you then to find mu or anything. Leave that for grade 12 maybe. Okay, so sometimes you give an E lost, sometimes you need to find it and then find friction. So now you can practice a bit more.